Hello and welcome to the Daily Space for today, May 3rd, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a variety of news coming to us from all over the universe and all over the world. So without further ado, let's just kind of dive in. Our first story today is a tale of globular clusters ruthlessly stolen and incorporated by the galaxy M106. This is, like most of our stories today, a story of violence and merger. Sometime far in the distant past, this beautiful galaxy here, imaged by a telescope in the Canary Islands and shown to you in fabulous false color, this particular galaxy grabbed a whole bunch of globular clusters, pockets of extremely old stars that all formed together, as well as a bunch of gas and dust, and incorporated all of these globular clusters and all of this material into a disk. Now, the reason that we think that these are ruthlessly stolen is, well, our own globular clusters seem to form a sphere around our galaxy. So we think that if a suite of globular clusters forms with a galaxy, they form in a sphere, whereas these, with their own specific set of motions, appear to have been more cannibalized, where you start with your M101, then you have another disk of galaxies that comes in, and as it comes in, its angular momentum causes all of its material that may have previously been in a sphere around that early galaxy to instead get stretched out into a disk. Now, this is one of those things that astronomers are probably going to go back and forth on several times, as we do with our own galaxy's globular clusters. The reason that globular clusters can be so frustrating is we don't entirely know how they form. The leading theory right now, in my opinion, and there's many theories out there, is that these form in the compressed regions of gas and dust that can end up getting shocked together when galaxies merge. We've seen examples of what appears to be globular clusters forming in merging galaxies. We don't know. We don't know for certain if that's how they form. And without knowing for certain how they form, it's awful hard to figure out their history. In our own galaxy, we have globular clusters that orbit in different directions, have a variety of different compositions, and this has led us to believe that some of them are stolen, some of them are natural, and we're not entirely sure what a natural globular cluster means. So until we figure that out, this is cool. This is consistent with one line of reasoning, and we know that galaxies are not nice and friendly things. They are violent things that like to steal. And it appears that M106 is a thief and a galaxy. In other news, we have an image that looks pretty much like nothing because it is an image of one of the darkest regions on the sky. Contained within this field is the original Hubble Deep Field. This is what happened when the director of the Hubble Space Telescope used his director's discretionary time to point the telescope at the darkest known, emptiest known place on the sky. And when Hubble did this, it revealed hundreds of galaxies. Now, in the nearly 30 years that the Hubble Space Telescope has been around, it has been slowly but surely building up image after image. And in particular, for the last 16 years, it has been working to mosaic out a contiguous field on the sky, taking adjoining images. In fact, it has taken 7,500 individual images. This totals to more than 250 days of observing time over the last 16 years. And when they put all the images together, they got this. And this particular field, thank you, Fort Richmond, for following. Oh, my dog is excited. when they put all of these images together, they found, well, there are 265,000 galaxies in this field. 265,000. Now, while across this stream, embedded in this particular field, this image may not look like much. I would strongly encourage all of you to go look at the high-res images, to upload them onto your computer and expand them out as much as your monitor allows them to be spread out. And for those of you who don't know why I'm currently feeding my dog Cheerios, we have a tradition on this channel that whenever someone donates bits, my dogs get Cheerios. But my dog can't tell the difference between the sound of somebody following and the sound of someone giving bits. So he gets Cheerios for both. And we are grateful for every new follow. And this is our way of thanking you with cuteness. Oh, here we go. More doggy cuteness is being demanded. I know, you're sitting so pretty. You're sitting so pretty. Come on up. So here we go. Thank you, Nebula Cluster, for the sub. Thank you so much. Hi. Hi. I know you have made my hand nice and slimy. So in other news, continuing the story while continuing to reach for Cheerios. In other news, come on up. Yesterday, there was a press conference from the good folks at the Ligo and Virgo consortiums. These two different suites of instruments spread across the globe are using lasers to very precisely detect the, well, shape of space-time. The way this works is they shine a laser between two different mirrors, and then they shine it between another set of two different mirrors. And where the light comes together, they look to see if it comes together to interfere in a positive or a negative way. Do the light waves combine to make a brighter spot? Do they counteract one another to make darkness on the detector? And what exactly they see depends very precisely, down to the wavelength of light, of how long the separation between those mirrors is. And if that separation changes at all, such as when, well, the Earth distorts due to a truck, or the Earth distorts due to a passing gravitational wave, they're there to detect it. Now, the reason that they have multiple detectors is so they can separate out when a truck goes by from when a gravitational wave occurs. Now, when they first launched, they saw nothing. They saw nothing for like a decade. And they kept improving their technology and improving their technology. And finally, a couple of years ago, they started finding gravitational waves. And now, with an even more updated system, they've expanded the volume of space that they believe they can probe by roughly a factor of 8. And within just a couple of weeks of turning on their new and improved sensors, they have detected 3 black-hole mergers, 1 neutron-star merger. These are all things they've detected before, and they detected something they think is new, and this is a neutron-star black hole merger. Now, mergers of every possible combination should be happening. We should have white dwarf, black hole, neutron star, white dwarf, all the combinations of the high mass objects, as well as stellar cannibalism, where these high mass, high density objects are stealing material off of a nearby normal star. What's new here is that we're finally able to see this stuff. And the quote included in this press release is one of the best quotes I've read in a long time, so I'm going to take a moment to read it to you. These 2 new triggers, referring to the 2 new detections they've made, these 2 new triggers are further evidence that our universe regularly rings with the aftershocks aftershocks of colossal astronomical events, said Professor Sheila Rowan, director of the University of Glasgow's Institute of Gravitational Research. We'd been deaf to these sounds before the detectors equipped us with the opportunity to hear them, and each event gives invaluable new data points to expand our understanding of the cosmos. And this is what they're doing. They're sensing how the universe rings and changes its shape as these mergers occur. And that's kind of cool. Thank you, this.humble, for the follow. Okay. So I now have 2 dogs up here, so I'm going to switch views. So hopefully I can toss treats for both dogs to see. Or at least I heard a second dog. I may not have a second dog up here. If I do, she's not responding to Cheerios. Okay, so now you get to watch Eddie Grace. So that's today's news. It is one of those days filled with violence. We have black holes consuming each other, neutron stars consuming each other, black holes and neutron stars consuming each other, and of course, galaxies consuming galaxies. It's a dog-eat-dog world out there, and these dogs aren't eating Cheerios. They're eating each other. Anyways, my dog is eating Cheerios, and I will now answer your questions. While you type them in, I'm going to remind you to please at CosmoQuest X so I can find them more effectively. And while you type them in, I'm going to remind you, if you ever miss an episode live right here on twitch.tv/CosmoQuestX, you can catch us over on YouTube at youtube.com/C. I don't know what it stands for, but I'm pretending it stands for community /C/CosmoQuest. We work to get every one of these episodes up online as quickly as we can. And those of you who are already over there, thank you so much. I see your comments and I love the humor that you bring to all the things you write in. So thank you very much. Thank you for the bits. Thank you for the subs. Thank you for the follows. You are making Eddie a very happy doggo. I'm going to call Stella if I can. I suspect the other doggo is somewhere, but we'll see. If she heard me, she'll come. Okay, so in addition to following us on YouTube, if you want to do more than just watch, if you want to support making sure this show keeps happening, check us out over on patreon.com. Your subs here on Twitch and your follows over on patreon.com are the 2 best ways that you can support us, because this provides us income month after month. So we know going in, if we cover all of these launches, we can actually pay Annie all the time that she is worth here on this channel. And once we bring in enough money, we'll be paying me too. So it's all very exciting. So these are the ways you can help us. And as always, we are part of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system. So thank you. And I am now going to check out your questions. Scrolling back. Hello, Astro B. I love that you say hi every time. Please keep doing that. It brings me joy. Hello, DPI209. But at me so I can find it better next time. Okay. Hello, Jandra Loon. I see your remote going hi. I love your comments on our completely accurate orbital dynamics intro. Let's see. Our intro has some new flags. They're awesome. And he has butterfly wings as well. Okay. And Nebula Cluster, I'm just going to thank you again. Thank you for your sub. That's 2 months in a row, and that is fabulous. There's no Hanny's Vorverb here today. That is sad. I hope they're okay. So Astro B is asking, do gravitational waves get absorbed as they go through our planet? I don't think absorbed is the right word. They are radiating through space, and the larger their volume gets, the less energy is in any particular area of the wave. Just like sound waves, as they radiate away, get weaker and weaker, and we don't hear the sound as loudly when we're far away from something as when we're up close. Now, with gravitational waves, as they radiate through space, their energy is getting spread over a larger and larger surface, and they're simply deforming space-time as they go. So it's not so much that the Earth is absorbing energy out of them as they're deforming the universe, and the Earth happens to be part of that. It's kind of awesome. It's one hell of a superpower to be able to deform the universe. Okay, let's see what else is in here. Stormer John asks, how can LIGO determine what sort of merger has been detected? It has to do with the frequencies. It's sort of like some people can listen to a musical instrument and tell, is that a clarinet or an oboe, even if they're playing the exact same note, because the harmonics are slightly different. And you can tell the difference between individual notes by the pitch. And the difference in the notes has to do with the size of the resonating cavity that is being created. With black hole mergers, neutron star mergers, and black hole neutron star mergers, the burst of noise that we hear, the burst of waves that deform our planet, and then scientists turn into sound because we're crazy like that. It's not actually sound. It's space deforming. This burst of waves that we're able to measure, the shape of that pulse of waves acts like an oscilloscope listening to those instruments instead of a person. Thank you, Bill Nash, for the sub. I'll read your question in just a moment. In this case, with our LIGO and Virgo detections, we look at the shape of the wave pulse and we're able to tell what instrument it is, black holes or neutron stars, just like an oscilloscope might be able to tell us similar things here on Earth. I hope that analogy worked. I got very distracted by the awesome sub coming in for 7 months in a row from Bill Nash, who asks, do we have enough measurement points to determine vector and distance of gravitational wave sources? Not precisely, but we're getting better. By scattering more and more detectors around the surface of the planet, we can actually measure the light travel time, or in this case, the gravitational wave travel time between different points, and that will give us a sense of where on the sky it is. The way to think about it is our planet is this three-dimensional surface. And if this detector over here detects the source first, and this one over here detects it last, that tells us that the longest path is between those two detectors versus between this detector and one up here. So we compare when each detector detects the gravitational wave, and the differences in timing tell us what direction the thing was. And we're actually working on developing now ways of quickly following up the way we used to follow up with gamma ray bursts. So give us time. You may be able to download an app for that. Let's see what else is in here. Yeah, Jandraloon, the work that they have done to, thank you, Ed Thompson, the work they have done to isolate and refine everything with the LIGO and Virgo detectors to finally be able to detect gravitational waves is impressive. I remain bitter at all the years and years and years of funding they got before they were able to build something capable of actually making detections. But they're doing it now. And yes, my dogs are named Eddie and Stella, both human names. And you may be thinking this is an astronomy channel. She's an astronomy person. It must be Stella after the stars. No, it's Stella from the Tennessee Williams play, because we spend a lot of time standing on the back patio shouting, Stella, just like out of a Tennessee Williams play. So that's that. I love seeing all of the emotes. You guys are all awesome. Thank you. Yes, our intro, just like that. No, it wasn't after the beer, Ed Thompson. That is not a beer I drink. I do drink Blue Moon. I'll admit to having that astronomically themed beer in my life. No, she's totally named after the Tennessee Williams character. Okay, so I'm not seeing any more questions. Later today, Bill Nash is asking, has Karga come online yet? Not yet. Not yet. Later today, we will be we will be recording 2 back-to-back episodes of Astronomy Cast over on YouTube. That will be starting at 3 p.m. Eastern, noon Pacific. That is 9 p.m. London time. No, it's not. It's 8 p.m. London time. You are all invited to join us over there on YouTube. Today's topics are going to be historical astronomy of South Central America, the Andes Mountains, and modern astronomy that takes place with all the great observatories down in that region of the world. Now, the reason that we're doing 2 back-to-back episodes is next week I am going to be in Budapest for the Craft Conference for software developers. This is one of those cases of, oh, wow, wow, don't feel worthy. I am the opening speaker, and I'm so amazingly grateful for this amazing opportunity. Imposter syndrome is real, but I hope to make everyone proud. The talk will eventually be out on the internet. Thank you, Trekker Kev. So once I have the links, I will be sharing the links over on Twitter. I will also be sharing pictures and all that sort of stuff on Instagram and Twitter as I can. I personally am Starstrider with a Y because mistakes were made in my 20s. So go ahead, give me a follow, and find out all the awesome stuff that is going down as I talk about all the ways we use software to explore our universe. And I think that's it. I think that's all I've got for today. So thank you all for being here. We will return on Sunday with Annie Wilson for the Sunday Science Hour at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. I will be back, hopefully on time on Monday. There may be a bit of chaos next week. I'm going to try and avoid that. I am getting in Sunday, and the first thing I'm going to be checking is how good is the Wi-Fi. Thank you so much for the bits. Thank you. There. Happy douche. Very happy douche. Thanks for being here. And I am now going to look and see who I can raid. And yeah, I see the comment about Peter Mayhay. He did pass away on April 30th. This is the fine actor who played Chewbacca in the original series, in the Star Wars Christmas special. And he was just a fine gentleman overall. I did have the honor of getting to meet him at a science fiction conference. And what's amazing is how hard he's worked to keep his giant body working for so many years. And yeah, it's kind of awesome that he was able to accomplish so much for so long. Anyone whose body is a little too big or a little too small has to fight. And he was a fighter, and he was an excellent human. So be at peace. And we're going to raid Oh Bother. We're going to raid Oh Bother. So I'm going to awkwardly, because that's the only way I know how, find and start the credits. And I'm going to remind all of you that wherever you are in the world, you should go out and look up. We are one people sharing one sky. And have a fabulous morning, evening, or afternoon, wherever you may be. Bye-bye.